One, two, three. Assalamualaikum and hi. We are from Group 7. We'll be presenting our analysis of evidence. This is the table of contents. Let's get started.
So what is the role of forensic chemist? Forensic chemist applies analytical and spectroscopic techniques to examine physical evidence in criminal investigation. They are frequently encountered in drug-related crimes and also overdose cases. Common analgesic and antipyretic involved in poisoning cases due to accidental or intentional overdose. They are widely available and easy to access. Overdose detection is crucial in medico-legal investigation. In this project, we use SEM and also UV spectroscopy. So this is the objective of this project.
Was chosen for this forensic analysis due to its importance in clinical and toxicological cases. It is a widely used analgesic and antipyretic commonly found in households. However, it is often involved in accidental or intentional overdose which can cause severe liver damage or death. This factor makes it highly relevant in forensic toxicology, particularly in suspected drug misuse or poisoning cases. This study used two forms of paracetamol. First, pure paracetamol powder as a standard sample for UVB used to determine lambda max and yield calibration curve. The second one, a commercial paracetamol tablet ground into fine powder as the unknown sample was dissolved for concentration analysis. Both samples were also analyzed using SEM to observe their surface morphology and particle characteristics.
Methodology. For ACM, 5 mg of each powder sample was placed on an aluminum stud with a double-sided carbon tape. Those particles were removed using compressed air. The stud were then coated with a platinum to enhance conductivity and prevent charging during imaging. ACM image was conducted under high vacuum with an accelerating voltage of 10 to 20 kV. Micrographs were taken at 100,000 and 10,000 magnification to compare paracetamol morphology, texture, and size between pure and commercial paracetamol. Observe different help identify possible excipients or manufacturing inconsistency in the commercial sample. For UV analysis, a 500 mg of Panadol tablet was accurately weighed and dissolved in 100 ml of distilled water. The mixture was stirred, then filtered using wet filter paper to remove insoluble excipient. The clear filter was collected for analysis. Paracetamol concentration was determined by measuring the sample absorbance and comparing it to the calibration curve with the equation of y equal to 0.0974x plus 0.0143.
At 100 magnification, both samples showed similar particle shapes and size distribution appearing as block-like crystals. This low magnification gave a general view of particle aggregation and surface coverage, indicating uniform and well-defined crystallinity, suggesting proper crystallization during synthesis. At 1000 magnification, both samples showed smooth crystal surfaces, sharp edges, and uniform dimensions. Their crystal morphology and surface alignment were highly similar, indicating comparable crystallization and drying processes, with minimal impurities or structural defects. At 10,000 magnification, both samples revealed fine surface features and micro-textures. The surfaces appeared smooth with similar micropatterns, confirming the absence of contaminants, structural dislocations, or irregularities that could differentiate the samples. UV spectroscopy showed an absorbance of 0.9824 at 243 nanometer based on the calibration curve. The calculated paracetamol concentration was 9.94 microgram per milliliter per 100 milligram of powder. With 3.036 gram of tablet used, the total paracetamol detected was 301.6 milligram, which is only 62.3% of the labeled 500 milligram content. The discrepancy may be due to incomplete dissolution, leaving undissolved paracetamol unmeasured, sample loss during preparation or filtration, degradation from light heat or pH, interference from excipients affecting absorbance at 243 nanometer.
Alright, so the conclusion that we can make from this is that SEM analysis at varied magnification showed no significant differences between pure and commercial paracetamol, which confirming their identical molecular structure and jet synthesis rock. Both samples have well-defined block-like crystals with smooth surface, which indicating consistent stability and purity. However, the UV-based results show only 301.63 milligram of paracetamol in a 500 milligram tablet, which only just 60.32% of the tablet amount. So this may be due to incomplete dissolution, sample loss, or degradation. But despite the similar ACM profiles, the findings emphasize the need for accurate sample handling to ensure the reliable analytical results.
This is our list of references. That is all from us. Thank you.
Here! I'm gonna put some here. Okay.